Okay, course 2 guys, I almost forgot about the Investigation 9 graphing functions, and this is a kind of a complicated one, so keep up with me if you can. Alright, so the first one we have here says y equals 2x. Well, that's pretty easy. So if x is 0, then 2 times 0 would be 0. If x is 1, then 2 times 1 would be 2. If x is 2, then 2 times 2 would be 4. If x is 3, then 3 times 2 would be 6. Easy. These, as you know, are your coordinates. So you make a coordinate graph, and you graph them, and you draw a line. And now every single point on this line will follow this rule. Don't believe me? All right, let's look. Here we have, this dot is at a half. That's my x, right? So if x is a half, then y is going to be 2 times that half. What's 2 halves? 1. Where is y? Oh, look, it's right at the 1. So half and 1. And you can do that throughout, and you will see each point fits this function. Okay? Pretty cool. All right, so now, and it's going to always be in a line because it could go this way and this way forever and ever and ever and ever. Okay? Any point on this line will fit the equation y equals 2x. Now, what if we wanted to graph the perimeter of a square? Okay, well, p equals 4s. This time we're going to say p is y and s is x. Okay? So for every one side, if you multiply times 4, you'll get 4. If you have 2 sides, 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. Put that on a graph, and it will be a ray. It can't go into the negative numbers because you can't have a negative part of a side, right? You can't have one side measure 1 and the other side measure -1. No. So for this type of function, it's only going to be a ray. It is not going to go down here into the negatives. Okay? That part is pretty easy. All right, let's see what we have coming up. Oh boy, we can graph distance and time. Here's an example. Sam walks distance in how many hours? All right, so it tells us that the distance is going to equal 3 hours. So the h is going to be the x, the y is going to be the d. So every 1 hour, he walks 3 miles. Now, if he has 2 hours, 2 times 3 would be 6. 3 times 3 would be 9, right? So how do we graph? How do we graph for time? Well, we're going to say distance in mile, that's our y-axis, and the hours is our x-axis, correct? So I split the hours into quarter hours, right? So it's easier to see it on the graph that way. So in 1 hour, he went 3 miles. In 2 hours, he went 6 miles. In 3 hours, he went 9 miles. And look at that, we still get a nice ray, correct? Because you can't walk in negative time, right? You'd have to be the Flash to do that. We are not the Flash. All right, so we can use this information, this logic, to tell ourselves to fix this one. Okay, so what if he jogged 6 miles for 2 hours? Create a function table. All right, so let's say in 2 hours, in 2 hours he went 6 miles. All right, well then how many miles would he go in 3 hours? Well, here, let's write the function. So look up here, how are we going to do it? We're going to have d equals. So d equals, what did we multiply? What times what is, or 2 times what is 6? Would be 3, right? So d equals 3h, correct? 2 times 3 is 6. All right, so what if we did this for 3 hours? Well, 3 hours times 3 would be the distance of 9. What if he could do it for 4 hours? Oh, he'd be a champ. 4 times 3 is 12. That would be 12 miles. Oh my goodness. Okay, so let's graph this. We have our hours as the x-axis and our distance in miles. And yes, I made a mistake. I want it to be longer. Again, I divided my hours into quarter hours, so it's easier to read. So in 2 hours, he went 6 miles. In 3 hours, he went 9 miles, way up here. Let's see if I can do that. And in 4 hours, he went 12 miles. And if I had a nice ruler, I could draw a really nice line that went all the way. Oh yeah, see how I miss? But you know what I mean. So let's make a nice straight ray. All right, so far not so tough, right? All right. So far, all of those functions we've looked at have been direct variations. That means when one variable changes, it results in a proportional change in the other variable. What? Okay, so think this. If I'm paid by the hour, then the more hours I work, the more I'm paid. They're related to each other proportionally, right? And because it's proportional, we can form a proportion with two pairs of number. So let's say I work at 1 hour, I get $5. So 2 hours, I'll get 10, right? 3 hours, I'll get 15. 4 hours, I'll get $20. I can pick any one of these and make a proportion that will equal. How do I know that? Well, let's just go. 2 is to 10, and I'm going this way because we have hours and money, right? You can't do hours to hours and money to money. So hours to money. 2 is to 10 as 3 is to 15. All right, well, cross multiply. 10 times 3 equals 2 times 15. Does it? Oh, yeah, 30 equals 30. So an equation with variables that are directly proportional has this form. Don't get scared. It's not hard. Y equals kx. K just means the constant. Here, in this example, $5 was the constant, correct? However many hours I worked, I earned $5 per that hour. So 5 was the constant. It did not change. All right. Let's look at the next thing. Why can't I just flip pages? Good grief. Because I'm slow. All right. Which is not an example of a direct variation? The lengths of the side of a regular hexagon and the perimeter. Well, do those two directly correlate? Yes, right? The length, and you add all the lengths. Of course it's going to be proportional. The number of books in a stack and the height of the stack. Well, if I have 3 books, they're going to be 3 books high. If I have 2 books, they're going to be 2 books high. So yes, they are proportional. The speed at which you travel to school and the time it takes to get to school. Well, let's think about that. Let's say I can go 40 miles an hour. Is that the only variable? No, there's going to be stoplights, there's going to be traffic signals, there's going to be pedestrians. This is not a direct variation. How about this one? A length of a segment in inches to its length in centimeters. Well, yeah, that's set, right? We know that every inch is 2.5, or every centimeter is 2.5. How's that go? Every inch is 2.5 centimeters. All right, 2.54. All right. The graph of a function with a direct variation is always a straight line or array that includes the origin. So which of these would be a direct variation? Only B. That's right. That's the only one that's a straight line that includes the origin. This one is just off. This one's all wackadoodle, and this one's way off. So this is the only one that's a straight line or array and includes the origin. So if you see that, you're going to know, oh, that's a direct variation. All right, let's look at some more. Inverse variation. Don't get scared. Don't get scared. New words, not hard. Inverse variation is a relationship between two variables in which a change in one variable results in an inversely proportional change. What? For example, one variable doubles times 2 and the other is half times the reciprocal times 1/2. All right? Rate and time are an inverse variation. We have rate, we have time, we have distance. This would go to if I travel 40 miles an hour to school, and what time will I get there, right? Now, the distance is the constant. From my house to school, the miles never change. It's always going to be 10 miles to school, right? The rate and the time are the variables. How fast I go and how long it's going to take me. Distance, it's always going to be 10. So the rule is, or here, we'll do an example. Well, here's the equation. Rate times time equals distance. So let's say Adam travels 2 hours at 60 miles per hour. There's the time. There's the rate. So you're going to multiply these two, right? Rate times time. Distance is 120 miles. That is my constant. So I can change my variables as long as they multiply and add, or multiply and give me the answer of the product of 120. So 60 times 2, yep, 2 hours, 60 miles, that equals 120. What if I then went 40 miles? How long would it take me? It would take me 3 hours, because 3 times 40 is 120. What if I only went 30 miles an hour? Then it would take me 4 hours, because 4 times 30 is 120. Remember, my miles aren't changing. I need to go from point A to point B. That's not changing. What if I only went 20 miles an hour? It would take me 6 hours, because 6 times 20 is 120.